Hello guys, let's start about the same electronic configurations. Previously we discussed about the electronic configurations of few elements, and let's see few more elements. And for that you must know this. First I was given very clearly, this is 1s and next is 2s, and next here you have 2p. So no need to confuse, I told you. Here what the number you have, those many subshells will be present in each shell. This is K shell I told, this is L shell, and the M shell has 3s and 3p and 3d you have, and next here you have 4s, and this is 4p and 4d, and next will be 4f, like that you have. Okay, and next 5s and so on, like that, and next will be 5g I told you. So every shell will consist new subshell I was given previously. So how to fill electrons means one by one in the increasing order of their energy of subshells. So first you have to fill 1s, and then you have to fill 2s, and then you have to fill 2p 3s, and then 3p 4s. These arrows like this you have to fill, I was given already. Next 3d 4p 5s, like this. So first 1s you have to fill. The 1s, this is the starting point and this is the ending point. The starting point, ending point, starting point, ending point. Okay, so 1s after what you have to fill? 2s. 2s after what you have to fill? 2p. 2p after what you have to fill? 3s. What you have to fill? Fill with electrons, right? These subshells. Depends on what? Their atomic numbers. Okay, so 3s after what you have to fill? 3p. 3p after 4s. 4s after 5s? No. 4s after 3d. Interesting thing. 3p after not 3d, you observed or not? 3p after complete filling you have to fill that 4s. 4s after you have to go for 3d. Okay, so from this let's see the order, that's better. Okay, so one by one. So first what you have to fill? 1s. 1s is less than as equal. Well, like simply write down. So first you have to fill 1s. 1s after 2s. 2s after 2p. 2p after 3s, 3s after 3p, 3p after 4s, 4s after 3d, and so on, like that. Up to 30 elements to fill. Up to this or this energy order is enough for us. Okay. So from where we started means from 1s we started. How many electrons will be present means I was very clearly given. S will take 2 electrons and P will take 6 electrons and D will take 10 electrons. F will take 14 electrons, I was given very clearly. Any S subshell, whether that is 1s or 2s or 3s, 4s, whatever, any S subshell will have maximum 2 electrons, and any P subshell has 6 electrons, can have 6 electrons. Any D subshell can have maximum 10 electrons. Any F subshell, 4f, 5f, 6f, whatever, F subshell will have maximum 14 electrons. Getting what I am saying? So D subshell, any D subshell, 3D, 4D, 5D will have maximum 10 electrons. Every video I am giving you just a small recap for 5 minutes, like that. Okay, so let's see, without wasting time, let's see the electronic configurations one by one. I was given previously up to, I think, carbon I was given. Again from carbon I will write, not a problem for me. So atomic number I am writing here, and here I will write what is the element, and here I will write Mr. Electronic configuration. So here you have first atomic number 6 I was given. Okay, and here from 5 if you want I will write, no problem. 5 is Mr. Boron, and atomic number is 5, means how many electrons will be present? 5 electrons will be present. So what is the electronic configuration? It's 1s2, 2s2 and 2p1. Why I am writing from boron again? Because 2p starts from here. See, 5, atomic number 5 means how many electrons we have to fill? 5 electrons. As I told you, here 2 electrons, here 2 electrons, here 1 electron. 2 plus 2 plus 1, total 5 electrons. Because S can have maximum 2 electrons. So 1s2, 2s2, 2p1. Because this is the increasing order of energy. Increasing order of energy, this is. Hofbauer what said? Increasing order of energy we have to follow to fill electrons in various subshells. That's it. Okay. So you have a boron. And next, sixth one is Mr. Carbon. 2p maximum will have how many electrons? 6 electrons. So what will be the configuration therefore? It's a 1s2 and 2s2. It's a 2p2. See, it's carbon. Atomic number is 6. These powers will give you the number of electrons. It's a representation of electrons in various subshells. 1s consists of 2 electrons, 2s consists of 2 electrons, and 2p consists of 2 electrons, and this is very important. For carbon, atomic number is 6. It's very simple. How they will ask question, what is the electronic configuration, is one question for carbon. In carbon, in L shell, how many electrons are present means very simple. This is K shell and these two comes under L shell. How we are saying, sir, these two comes under L shell means N is equals to 2. N is equals to 1, K shell. N is equals to 1 means what I told you, K shell. This number will give that particular shell. 1 K shell, 2 L shell, 3 M shell. Here I was given 3 M shell. Okay, like that you will have. Next. Come to, suppose that's a question I was given. In carbon, L shell consists of how many electrons? That means 4 electrons. Understand? Okay. Next one is atomic number 7. Who is that? 7. Atomic number 7 is Mr. Nitrogen. Nitrogen configuration is 1s2, 2s2, 2p3. 1s2, 2s2, 2p3 configuration. This is the configuration of Mr. Nitrogen. Hope you understood? Okay. See, P is increasing here. In P, the electrons increasing here, right? P1 here, P2 here, P3 here. So electrons entering into what subshell? 2p subshell here for nitrogen. Last electron is called differentiating electron. While giving electronic configuration, I am giving you new things here. Electron where lastly entering is called differentiating electron. See here 2 electrons. Here third electron was entered into 2p. So in nitrogen, differentiating electron enters in what subshell? It's 2p. That's the main important thing. Okay, next 8 is Mr. Oxygen. Oxygen is 1s2, 2s2, 2p4. And next 9, Mr. Fluorine. 1s2, 2s2, 2p5. Okay. Next 10, Mr. Neon. Neon is 1s2, 2s2, 2p6. It's a very important thing, because the shell was completely filled. This is K shell and this is L shell. Here helium I was given previously. K shell was completely filled. Helium 1s2. If the shell completely filled, or they consist of 2s2, 2p6, that is called octet configuration. Octa means 8. 2 plus 6, 8. Octet. This is also called what we called, inert gas configuration. Inert gas configuration means this last shell ns2 np6 we call generally ns2 np6. This is in general ns2 np6 is the inert gas configuration. I am not only giving the electronic configurations one by one, I am giving you what is the differentiating electron, what is the last shell I was given. Last shell is L shell here. Okay, here I was given octet configuration. Helium also like that. Helium is 1s2 I was given. Of course, that is a duplet configuration. Remember this duplet configuration. I'll ask you questions in assignment tomorrow. Okay, so you must answer. Helium has a duplet configuration. Duplet, du means 2. Duplet means 2. Okay, so 2 electrons is present helium, that is also inert gas. The neon is inert gas, everybody. So 1s2, 2s2, 2p6, the shell was completely filled. Of course, ns2 np6 is the configuration of inert gas configuration, or else that we call as octet configuration. This we call as octet configuration. What configuration? Octet configuration. Very, very important for us. Okay, this is about what is inert gas configuration. The differentiating electron is what? What is the differentiating electron? Differentiating electron enters into what subshell? These kind of things I am giving here. Be careful and keep it here. Okay, thank you. And next elements, let's see one by one. See that is very important. That side, what you have, this one. Which one? This particular. What is that? 1s is less than. I was given, you also write down left side all these energies. That is very, very important. 1s is less than, 2s is less than, 2p is less than, 3s is less than, 3p is less than, 4s is less than, 3d. Up to this you just remember everybody. By using these only we are writing electronic configuration. See, till now if you observe, first I was filled 1s and then 2s and then 2p I was filled. Till this 2p we filled. Means how many elements we learn, we can say. S will have how many electrons? 2. Here S will have how many electrons? 2. 2 plus 2? 4. P will have how many electrons? 6. That also you write down again. S will have how many electrons? 2 electrons. P will have how many electrons? S will have maximum 2 electrons. P has maximum 6 and T has maximum 10 electrons. These two things you please remember everybody. F will have how many electrons? 14 I was given. Now come to the next is atomic number. Excuse me. Atomic number is Mr. 11 and element, and next you have Mr. electronic configuration. Okay, so here what is this? Atomic number 11 is Mr. sodium, and the sodium configuration is 1s2 and 2s2, because it's 11 electrons, 1s2, 2s2, 2p 6, 1s2, 2s2, 2p 6, so 10 electrons over. So next is called differentiating electron, because 11th electron, total 11 electrons, up to here 10 electrons. 11th electron, differentiating electron enters into 3s, so it's a 3s1. You just keep it in your mind. Here what subshell was new, I was written 3s1. Okay, so hope you understood. Till here is the neon and the 11th one is the sodium. So the differentiating electron means new electron, new. Okay, so the new electron enters into 3s1. Got it? So next electron enters in what means 3s1. This you have to remember. Sodium it is. Okay, next is 12. Atomic number 12 is Mr. magnesium. I will write one by one. Is 13 Mr. aluminium, and 14 is Mr. who is that? Silicon, and Mr. 15 is phosphorus, and 16 is the sulfur, and 17 is Mr. 17 is who? Mr. who? 17 is chlorine, and Mr. 18 is argon. Okay, till here you must write the electronic configurations one by one. Let's see. The magnesium configuration is 1s2, 2s2, 2p6 and 3s2 and 3p. Oh no. Okay, 12 is magnesium, 1s2 and 2s2 and 2p6, 3s completely filled here. Okay, so magnesium is atomic number is 12. 2 plus 2 plus 6, 10 and 10 plus 2, it's a 12. Okay, this same you can write like this also. It's neon, 3s2, neon, you can write like this. Because I told you already, this is called 1s2, 2s2, 2p6 is called neon. So neon 3s2. The same way here also you can write. This entire thing is what you can write. It's neon and 3s1 you can write. Got it? So come to aluminium. Of course I'll write maybe options they will give like this. That's why I am representing that also. Okay, aluminium is 1s2, 2s2, 2p6 and 3s2 Yeah, till here 12. So up to here 3s was completely filled. 3s3 we cannot write. So next electron must enter into 3p. So 3s2, it's a 3p1, right? 3s2 3p1. Of course, maybe in your 10th standard, mainly for CBSE students, maybe you learn like this, 2, 8 and 3 like that. That is also correct. We have nothing to say wrong, but no need to, because like this only we have learned. Because in future, chemical bonding and group elements and what's the nature of bond, everything to understand, this kind of electronic configuration is more useful for us. So forget about that and just remember all these things. Okay. So again, same story in K shell. This is L shell and this is M shell. M shell consists of how many electrons? 2 plus 1, 3 in aluminium. The question is, in aluminium, the number of electrons present in M shell, M, capital M. Okay, capital M means third shell. This is K shell, this is L shell, this is M shell. M shell consists of 3 electrons here. Hope you understood, right? So next come to Mr. Silicon. What is the silicon configuration? Is 1s2 and 2s2 and 2p6 and 3s2 and 3p2 you have. You can check once, up to here 10 and 10 plus 4, 14. Okay. 3p also can be filled up to 6, because 3p, p can have maximum how many electrons? 6 electrons, as I told you. Okay. Now phosphorus is having 1s2 and 2s2 and 2p6 and 3s2 and 3p3 you have. Hope you understood. Next, come to the sulfur is 1s2 and 2s2 and 2p6 and 3s2 and 3p4. Next, Mr. Chlorine is 1s2, is 2s2, is 2p6 and 3s2, 3p5. Next, argon is having 1s2, a 2s2, a 2p6, 3s2, 3p6. Yes, again, argon is an inert gas, because see this carefully, what you have in the last shell. Last shell means the highest N value. This is the first shell, K shell. This is the next, second shell, L shell. This is the third shell and which is the last here. So this is M shell. Here also consists of 2 plus 6, 8 electrons. So this argon also what we called is inert gas. Inert gas. Up to 20 I will write now. Okay, 18. Next 19 is Mr. Potassium and Mr. 20 is calcium. So potassium is having 1s2, 2s2, 2p6 and 3s2 is 3p6. Actually up to 3p6 is the argon. So fully up to here is argon. And next what you will have, the electron enters into 4s1. That you can write very clearly like this, okay, at one place. What you have here, Mr. Potassium. So 1s2 and 2s2, 2p6 and 3s2, 3p6 up to here argon, and after 3p electron enters into what? 4s. So here it's a 4s1. Why I am writing with the red ink? Up to here is argon. So what you can write here again? Argon 4s1, right? Till here you can write neon 3s2 3p6. Neon till here you can write is neon. This is neon, 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 neon. Okay? Neon 3s2 3p3, neon 3s2 3p4, neon 3s2 3p5. Like that you can write. So potassium also or, okay? Or. 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. Argon 4s1 also you can write. That is a potassium configuration. This or this, don't get confused. And next calcium is calcium. If you want, I will write by giving some space. This is a calcium. What is that? This is 1s2 and 2s2, 2p6 and 3s2, 3p6 and 4s2. See, now 4s also filled up to calcium. See, magnesium 3s2. 3s was completely filled. So magnesium and calcium comes under same group. Like that also you can identify. See, sodium 3s1, potassium 4s1. So sodium and potassium comes under one family. So the configuration if same in the last shell, they are called one group, they are called one family. Okay, so this up to 20 elements we discussed. How many we discussed here? 11 to 20 elements we discussed. Next 10 elements if we discuss, it will be over today's class. Okay, so up to calcium we discussed. Next 21 means electron enters into where? You tell me. Where you will say? After class. Okay, next electron enters into 3D. See, 1s was filled first, next 2s, 2p, 3s, 3p, 4s. 4s was completely filled. How we are saying 4s completely filled? Electron enters into 4s and have maximum 2 electrons in 4s. S means 2, 4s, 3s, 2s, whatever. S means 2. 4s completed. So next element, 21 element, then electron enters into 3D. The last electron we are entering in 3D. That is called differentiating electron. That's very clear. I will ask you questions last. Okay? Hope you understood. Write down all these 30 elements electronic configurations. Let's see the next 10 elements electronic configurations. Okay, what are the electronic configurations from 21? 21 is scandium. Scandium. 21 is what? Scandium. As 22 is Mr. Titanium. 23 is vanadium. Okay. 24 is chromium. 25. Okay, scandium, titanium, vanadium, chromium, and manganese. 26 is iron. Okay. 27 is iron. Okay. Cobalt. And 28, can I write here? 28 is nickel. And 29 is Mr. Copper. And 30 is Mr. Zinc. Okay, I'll put 2 exceptional cases. About those exceptional cases, tomorrow we will discuss. In our next class we will discuss. Okay, next scandium. To see the same story, better to remember, better to write 1s is less energetic than 2s, then 2p, next 3s, next 3p, next 3d, oh shit, next 4s, and then 3d. So till here we filled electrons. Starting from 1s till here. Now electron we have to fill in Mr. 3D. This is the most important thing for us. So I am repeating. S will have maximum how many electrons? 2. P 6. D 10. What is the change? 4. Okay, that's very important. So now come to the scandium. It's very simple. It's 1s2 and 2s2 and 2p6 and 3s2 and 3p6 and 4s2 and 3d1. Here nothing will change. Till 4s as it is you can write, except for chromium and copper. For everywhere you can write like that. Okay. So electron, last electron, differentiating electron enters in what subshell? 3D in scandium. They'll ask question. In scandium, the differentiating electron enters in what subshell? 3D subshell. 3D can have maximum how many electrons? 10 electrons. It's very clear. So titanium now. So 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2, 3d2, 1s2 for vanadium already. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d3. Okay, so here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4, 24. So exactly from vanadium to chromium, this is correct. Here because if you observe it is 3d1, this is 3d2, this is 3d3, definitely it can be 3d4, but the configuration is it is 4s1 and 3d5, because D can have maximum how many electrons? 10 electrons. Fully means 10 electrons. Half means how many electrons? 5 electrons. D with 5 electron, any subshell with half electrons is more stable. That's why one electron will jump from 4s to 3d. In previous what you have here? In previous what you have? It is 4s to 3d, 4 you have. One electron jump from here to here. Then what you will have here? Here you have a 1 electron because 1 electron transferred here. 1 electron transferred here. So it became 3d, 5. So the last electron was entered into 3d. So you have 3d, 5 here. Hope you understood. This is 3d, 5. Where you have last electron? 3d. Why you are writing as 3d, 5? Because half electrons in D is very stable. Of course in P also stable. Okay, you may have a doubt for carbon itself, but I'll tell you later on. But for carbon it cannot jump. Energy is more required to jump. It won't happen. But in D subshell, it can, energy gap is less. So from 4s, electron can easily enter into 3d. So that's why we written as 4s1, 3d5. Correct? So this is the most important exceptional case. So the chromium electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1, 3d5 is the configuration. Please keep it in your mind because half electrons is more stable in D subshell or any subshell like a P, D, F like that, not S. S1 is stable, sir? No, one electron is not stable. For P, D, F, half of the electrons in maximum electrons, okay, is more stable. Okay, for D, how many maximum electrons? 10 electrons. Half means how much? 5. That's why 5 electrons is stable, so 1 electron transferred. Hope you understood. Okay, now come to manganese. You have 1s2, 2s2, 2p6, 3s2, 3p6. Now you can write 4s2, 3d5. You observed or not? 1 electron extra here. Actually 4s2, 3d4 na previous. 4s2, 3d4. Here 4s2, 3d5. Actually 4s2, 3d4, but 1 electron jump. That much only you remember. Once we entered into regular classes, that is very much different. Our classes will be definitely different. We will be at one place, we can discuss more and we can clarify more doubts. Okay, so now you have iron. So same manner, 1s2, 2s2, it's 2p6 and 3s2 and 3p6 and 4s2 and 3d6. Next is cobalt, 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2 and 3d7. See, observe, only this is the different. 4s2, 3d5, 4s2, 3d6, 4s2, 3d7. Now here, nickel is the same. Nickel. 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2, 3d8. Able to see what I written? 4s2, 3d8. Here next for copper, the same story. Copper is exceptional again like this. Chromium. So you have a copper here. So copper you have like this. 1s2, 2s2 and 2p6, 3s2, 3p6. Here also same story like this and 4s2, 3d9. Sir, one electron again will transfer, so it will be 4s1 and 3d10. If you have a very smart question, sir, here also d10 is more stable, no sir? Transfer 2 electrons. No, 1 electron can be transfer very easily. So 1 electron will transfer here, but 3d9 no use. So that's why in nickel no change. 4s2, 3d8. Because 2 electrons have to transfer here for nickel. It's not possible. So for copper it is possible because 4s2, 3d9. So 1 electron can be easily transferred. So it is 4s1, 3d10. So this is also exceptional configuration. Okay, 4s1, 3d10 is the copper configuration. Okay, same manner chromium you have a exceptional. Chromium and copper. So last and final for today class is zinc. What is the configuration, sir? It's a 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2, 3d10. This is the zinc configuration. Note it down all these things, and after maybe after completion of class you must send all 30 elements electronic configuration in our group. Thank you very much.